Meet Maya. It's a hot summer day, and she just set up a lemonade stand in her neighborhood. She's got a big question. The more cups she sells, the more money she makes. But which one controls the other? That's exactly what today's lesson is about. Independent and dependent variables, two math superpowers that help us understand how things in the real world connect. By the end of this video, you'll see patterns everywhere, just like Maya does. Let's go. Before we meet our two special variables, let's quickly review what a variable actually is. A variable is any quantity that can change. It's not locked in at one number. We usually write variables as letters, like X or Y. Think of a variable like an empty box that can hold different values. In Maya's lemonade stand, two things can change: the number of cups she sells and the money she earns. Both are variables. Now, here's the big question. Do they affect each other? Absolutely yes, and that's where it gets interesting. Here's where the magic happens. There are two types of variables, and they work like a team. The independent variable is the one you control. It's the cause, the starting point, the boss. The dependent variable is the one that reacts. It changes based on whatever the independent variable does. Think of it this way. The independent variable is like a light switch. The dependent variable is the light itself. You flip the switch, that's independent. The light turns on, that's dependent. One controls, one responds. Simple as that. Let's bring this back to Maya. She charges $2 for every cup of lemonade. The number of cups she sells is something she can't totally predict. Customers decide that. So cups sold is our independent variable. It changes on its own. But here's the thing. Her earnings depend on how many cups she sells. If she sells 0 cups, she makes $0. If she sells 5 cups, she makes $10. Her money earned is the dependent variable. It responds directly to the cups sold. See the connection? The equation says it all. Money equals 2 times cups. Maya's getting the hang of it, and now you will too. Here's a foolproof trick for identifying variables. Ask yourself 2 questions. First, which value can I control or choose? That's your independent variable. Second, which value changes because of the first one? That's your dependent variable. You can also think of it like a machine. You put a number in, that's the independent variable. The machine applies a rule, and a new number comes out. That's the dependent variable. Input and output. X goes in, Y comes out. This idea shows up everywhere in algebra and science. Here's a bonus superpower. When you graph these variables, there's a special rule. The independent variable always goes on the horizontal axis. That's the x-axis going left and right. The dependent variable always goes on the vertical axis. That's the y-axis going up and down. For Maya's lemonade stand, cups sold goes on the x-axis, and money earned goes on the y-axis. Every point on the graph shows exactly how much she earned for each number of cups. The graph makes the relationship visible. You can literally see how one variable affects the other. Let's look at Maya's actual lemonade data. She charges $2 per cup. When she sells 1 cup, she earns $2. When she sells 2 cups, she earns $4. 3 cups gives her $6, and 4 cups gives her $8. Notice the pattern. Every time cups sold goes up by 1, money earned goes up by 2. That's because the rule is always money equals 2 times cups. Cups sold is the independent variable. We plug it in. Money earned is the dependent variable. It pops out. Maya is starting to see this pattern too, and she's loving it. Let's try a new scenario, and this one hits close to home. Maya's friend Ethan is studying for a big math test. The more hours he studies, the higher his score tends to be. So which is independent and which is dependent? Hours studied is the independent variable. Ethan chooses how long he studies. Test score is the dependent variable. It depends on how much he studied. If the rule is score equals 10 times hours plus 40, then 1 hour gives a score of 50, 2 hours gives 60, 3 hours gives 70, 4 hours gives 80. Ethan studies more, score goes up. Classic dependent relationship. Ready for another one? Maya's family is going on a road trip. Their car uses 1 gallon of gas for every 25 miles driven. Miles driven is the independent variable. That's what they choose. Gas used is the dependent variable. It depends on the miles. The rule is gas equals miles divided by 25. Drive 25 miles, use 1 gallon. Drive 50 miles, use 2 gallons. Drive 75 miles, use 3 gallons. Drive 100 miles, use 4 gallons. Every time. This is exactly how scientists and engineers use variables to predict what will happen based on what they choose to do. Now let's test your skills, just like Maya is doing on her homework right now. She has 3 situations and needs to label each variable. Ready? Situation 1. The number of slices of pizza eaten and the number of calories consumed. Which is independent? Slices eaten. You choose that. Which is dependent? Calories. They depend on slices. Situation 2. The temperature outside and the number of people at the pool. Temperature is independent. It just happens. Pool attendance is dependent. It reacts to temperature. Situation 3. The number of songs downloaded and the total cost. Songs downloaded is independent. Total cost is dependent. Maya nailed all 3, and so did you. Maya wants to write a real equation for her lemonade stand to share with her parents. Let's do it together. She sells cups at $2 each. We let X equal cups sold. That's our independent variable. We let Y equal total money earned. That's our dependent variable. The equation is Y equals 2 times X. Now let's test it. Plug in X equals 6 cups sold. Y equals 2 times 6, which is 12. She earns $12. Plug in X equals 10. Y equals 2 times 10, which equals $20. The equation works every time. That's the power of understanding which variable is independent and which is dependent. Before we wrap up, here are some memory tricks that'll stick with you forever. Math teachers love the acronym DRY mix. Dependent variable responds. Independent variable is manipulated or chosen. When you see a graph, remember, independent goes on the x-axis, dependent goes on the y-axis. And the best trick of all, just ask yourself, which value reacts to the other one? The one that reacts is always dependent. The one it reacts to is always independent. Write these down, put them on a sticky note, whatever helps. These tricks work every single time. Look how far we've come. Remember Maya at the start? She had no idea why her lemonade earnings changed. Now she can write an equation, build a table, and even graph the relationship. That's the power of understanding independent and dependent variables. Let's recap. The independent variable is the one you control, the cause. The dependent variable reacts to it, the effect. On graphs, independent goes on the x-axis, dependent on the y-axis. From confused to confident. That's Maya's journey, and it's yours too. You're officially a variable master. Now go show off your